Okay, as promised, I'm going to start from scratch. We did the first 4 in class today, so just going to go back over those really quickly. The first one, remember what you want to do. It's always a good habit. Like if you get stuck, change everything into terms of sine and cosine. So on number 1, obviously we already have sine and cosine, so we're going to leave those there. But if I change secant and cosecant using those reciprocal identities, which I did post those by the way. I think I reposted the multiple angles twice, so sorry if that one's a repeat. But cosecant I know is 1 over secant is 1 over cosine. There we go. And cosecant is 1 over sine. And this is all multiplication, so what I'm allowed to do is be like, okay, this sine on the top goes away with the sine on the bottom. The cosine on the top goes away with cosine on the bottom, and you're literally left with 1. Like, that's it, because 1 times 1 is 1. Number 2, again, we know that it has to end up being 1. I just need to got to show your work on these first 4. Really, you got to show your work, I think, on most all of them, but I'm just saying. That's part of the simplification and improving process of these trig things. So like on this one, lots of different ways. I believe what we did in class today, if I remember correctly, is I changed this cotangent. Cotangent is the reciprocal of tangent. So that's 1 over tangent. And of course the tangent's going to stay tangent. And just like the previous problem, the bottom goes away with the top. And I'm left with positive 1. So that's number 2. And then number 3 got kind of fun. So number 3 was we used the Pythagorean identities. So the Pythagorean identity, pardon me, is, oops, I guess it really doesn't matter, is sine squared plus cosine squared is 1. Right? Like, that's the Pythagorean identity. And we're allowed to manipulate that however we want to, as long as our math is correct. And so, like, I can see in the top, I have sine squared minus 1, so I get really, really close to that. Like, if I were to do sine squared, or subtract sine squared on both sides, I end up with cosine squared is 1 minus sine squared, which is obviously very, very close to sine squared minus 1. But of course we know subtraction is not commutative. So what I'm allowed to do is go, okay, well, let's multiply both of these sides times negative 1, right? So if I were to multiply this side times negative 1 and this side times negative 1, what would happen is I would end up with negative cosine squared is equal to sine squared minus 1. It basically just flip-flops them, right? The negative times the negative is going to become a positive, and the negative times a positive is going to become a negative. So it flip-flops them. So you're allowed to do that. And I know that's probably a stretch in some of your heads, but like we know what we want it to look like, so we're going to make it look that way. So now that I know that that's what that looks like, I know that sine squared minus 1 is really negative cosine squared. I hate how they use those. And in the bottom, that was one of the odd even identities. Yes. Maybe. Yes. Anyway, cosine of a negative x is the same thing as cosine, just regular cosine x. Okay, so it's the same thing. It's on that sheet that I posted. And then just using algebra, I know that one of these goes away with this whole thing. And I'm left with negative cosine x, which is the answer to number 3. So that one was kind of a little fun. And then number 4 was the one, like, I see that you're trying to make the left side be equal to 2 cosecant. So the first thing I've got to do, like, I'm going to have to come down here. I mean, I already did it. I didn't erase it. I'm just going to do it over again, okay? Sine over 1 minus cosine. 1 minus cosine. What was it? Plus cosine times sine over 1 plus cosine. And we wanted that to equal 2 cosecant. Okay, excuse me, handwriting. All right, so obviously I'm going to work out the left side because it is definitely much more complicated than the right side. And I need to find a common denominator. And as we talked about, the common denominator is basically just the product of the two denominators, right? It's going to be 1 minus cosine times 1 plus cosine. Most of this problem is algebra. Just a little bit of trig sprinkled in. Okay, now obviously here on the bottom, I already have the 1 minus cosine, so I need the 1 plus cosine. Of course, that means I'm going to multiply the top times 1 plus cosine. And I'm going to just use the distributive property, right? I'm going to multiply that out. I'm going to kind of kill two birds with one stone here. So that's going to give me sine x plus sine times cosine, cosine times sine. It doesn't matter the order because multiplication is commutative. So that's that one. Now, same thing on the right side. Like over here, I already have the 1 plus cosine. I need the 1 minus cosine. So I'm going to multiply this times 1 minus cosine. And just like a second ago, I'm just going to use the distributive property here. And it is a plus sign in the middle, so I'm going to do plus. Sine times 1 is sine. And then sine times minus cosine would be minus sine cosine. And I ran out of room. Big old numerator. So it's finding common denominators, just, you know, a little more trigonometrically inclined. So what happens in the numerator? Like, I have a sine and a sine, combined like terms. I have two sines. Now, it's not multiplication, it's addition. So that's why it's 2 sine and not sine squared. If it's multiplication, it would be sine squared. And then the fact that this is a positive sine x, sine cosine, and this is a negative sine cosine, like those go away. It's 0. They add out. In the denominator, pardon me, what would happen? Like these two are conjugates of each other, right? The terms are the same, but this is a minus and this is a plus. And we have done conjugates the time we're 12. And the rule was, it's anytime you multiply conjugates together, it's the first term squared, so 1 squared, minus, always a minus unless we're doing imaginary numbers, obviously not here. And then the second term squared, which is cosine squared. Okay, so I just multiply that out. So that was, all of that was algebra. Now let's look at the trig part. So very, very similar to the previous problem, I see that cosine squared there, and I know that sine squared plus cosine squared is 1, right? That's our Pythagorean identity, and it would be really great if I had 1 minus cosine squared. So I'm allowed to go, okay, well, I know if I manipulate this just a little, by doing this right here and subtracting cosine squared from both sides. Oops. Oh, no. Okay. After this one, I'll take a break and charge my pencil for a quick second. I get sine squared is 1 minus cosine squared. Right? I just subtracted cosine squared from both sides. So now I can confidently go, okay, this is going to be 2 sine x over sine squared. Because 1 minus cosine squared, we just figured out, was sine squared. And a little bit more algebra. This one on the top goes away with one of these on the bottom. And I'm left with 2 over sine x, which is, well, because we know that 1 over sine x is cosecant. And so since there's a 2 there, I have just proved that all of that does indeed 2 cosecant x. And again, the big thing is I've got to see that work. That is the proof. Like, I know it equals 2 cosecant x. Thank you very much. I've already told you that. I've got to see how you work that one out. Okay, so that's 1 through 4. I'll post the rest in a minute after my Apple Pen charges.